I get the pleasure of talking in that long afternoon stretch when all the blood is rushing to your stomach from lunch. So I'll try to keep the slides to a minimum and hopefully keep everyone interested and awake here for a little bit longer. So as Steve mentioned, I'm the network architect for Indiana University. So I think that Steve and others today have done a great job of outlining the various use cases. I think the reason I'm here is to try to show, as someone who's responsible for the design and long-term planning of a very large enterprise network, as well as someone who's been spending most of their time for almost 3 years now working on various aspects of SDN and OpenFlow, to take those use cases and show how those apply to the big problems that we have on the university network. And I think these apply to other enterprise networks as well. So as a bit of background, I spent the first 8 or 9 years of my career in the WAN carrier space, working for AOL and UUNet, other large wide area networks. And about 6 or 7 years ago, I started doing some design for the Indiana University network, and I was completely blown away by the kinds of challenges, the big challenges that were coming down the pike for university networks, not just IU, but other large research networks. And so, loving a good challenge to try to solve, I jumped in, and I've been thinking about SDN for I don't know, 6 or 7 years now, and although I didn't think of it as SDN then, I was fortunate to have lunch with Dr. Doug Comer from Purdue while he was working at Cisco on network management. And he made this comment that we need to start managing entire networks the way we manage individual nodes in a network today. And as I was looking at the problems that we were facing 6, 7 years ago on the network, I thought, that's exactly what we need to do. That is exactly what we need to do. And a few years after that, we started playing with controller-based wireless, just as that was starting to come out. And I thought, wow, this is actually kind of like that. This is kind of what he was talking about. We just need this for the entire network, not just wireless. The kinds of things that we can do with controller-based wireless and being able to manage 5,000 access points across 8 different campuses, across 400 different buildings, the way we could roll out new SSIDs in just a couple minutes to a lot of different access points and manage that. That's the kind of management I want for the 100,000 switch ports that we manage in our network. Why can't I get that? That's what we want. That's going to help us solve these problems. So when you look at the kind of problems that we have, when I talk to people about university networks, I think there's this impression that, well, you can do all this cutting edge stuff because you really just have students and you have researchers, and you have this kind of playground network, and so that's how you can do this kind of cutting edge stuff. And that's not the case at all, right? Building a network for a large research university is like trying to network an entire city. Right? We have hospitals, lots of hospitals. We have 2,000 doctors that we support networking for that are also faculty members. We have doctor's office, eye clinics, dental clinics, all of these things we provide networking for. Restaurants, theaters, large sports venues. I picked some of the photos from our website here. We have police departments. We have publishers. We have all these things, large libraries. We are not just classrooms and lecture halls, right? We have, obviously I mentioned all the hospitals, so we have HIPAA requirements. We have PCI DSS compliance requirements. We have 12 different payment card systems, over 600 different point-of-sale devices connected to the network. We run our own electric and water utilities. I have 400 HVAC systems connected to our network. You can control the temperature in 400 different buildings through the IP network, right? So these are all the different things that we have to support. I point out we have 120,000 users, and 95% of those are BYOD. And we've been doing this for 20 years. We've been doing BYOD on a large scale for 20 years, and it's not that we don't have sensitive data to protect. We have lots of it, lots and lots of sensitive data to protect. So this is challenging. The other thing is, with an enterprise that big, it's a federated operation. It is not all managed centrally. When you look at security policy, we don't manage security policy and firewalls from one place. There's just simply no way to do it on that scale. When you have 6, 7 large hospitals, in addition to all these other things I mentioned, that has to be distributed. The people that are closest to those devices, that are closest to those services, need to manage those. So I like to say the challenges we face look a lot like the challenges that large multi-tenant data centers are facing. We had a call the other day with a vendor working on SDN, and the question came up, how are these problems different than large multi-tenant data centers? And the answer was, Fundamentally, they're not. We need to build one big, cost-effective, reliable network fabric that spans 100,000 different switch ports and thousands of wireless access points, and then we need to virtualize that, and we need to be able to delegate control of those slices of the network, those virtual networks, to those departments that are managing those. It's largely the same problems. We don't have a lot of hypervisor switches. They're mostly physical switches. We don't have virtual machines. We have physical machines. But largely the problem set is the same. So when we first started looking at this 2.5, 3 years ago, the picture I immediately saw was this picture on my left, right? And Martin Casado from the Sierra did a good talk at the summit last fall about how we have these great dynamic protocols for distributing state, layer 2 state for MAC addresses, layer 3 state. But when you get to layer 4 to 7 state, whether specifically security policy, how does that get distributed today? And the answer is we do it in a lot of different ways, right? You may have SNMP pushing filters into devices. You have a lot of people logging into consoles and configuring ACLs. You're pushing VLAN assignments or ACLs through Radius down to your edge switches. You have proprietary firewall management applications that are pushing firewall policies, and we have 2 or 3 different kinds of firewalls that you have to manage these for. But there's no one sort of global way to push security policy. So the first thing that kind of pops to mind is this picture on the left where you have this SDN controller where you can sort of distill down your security policy into one place and then push it using OpenFlow out to all the different devices. And so this first pops into mind, but the problem you have here is fundamentally that you're managing security policy based on physical devices. And your security policy doesn't really break down that way. If you look in any given building on our campus, we probably have 10, 15 different groups of devices that live in that building, whether it's security cameras or HVAC systems or Coke machines or students on wireless or servers for that department. So it doesn't break down along physical boundaries. So what you really start looking at is this picture on the right, where the only way to really manage security policy in this sort of environment is to group things together across physical space. Right, I need to take all of my payment card systems and group those all up. They're spread across 400 different buildings, but I want to group those all up, and I want to build my security policy on the traffic that goes between those groups. Right, and this is where you get back to that multi-tenant environment. One big fabric, virtualize the fabric, delegate the security policy down to those individual groups, and control your security policy on traffic moving between those groups. So that's where we're looking at now, and we're looking in a probably 1 to 2 year time horizon on how we do that right side picture on a really big scale on our network. The other thing I want to talk about is something that's more near term that we've already started working on. So I mentioned that we have something on the order of 120,000 devices that are not managed by us on our network. And we've been doing this for a long time. So we were doing NAC before we knew what the term NAC was, before that existed. So we have actually built our own NAC system. This has been in place for at least the 12 years that I've been there, and probably a while before that. So we actually have our own client that today comes down through a web interface. So when someone connects to our network, when a student connects to our network for the first time, they're presented with a web page. They get a captive portal. It's a walled garden system. They get a web page. There's a client that comes down to the machine. It checks some things out. It registers their MAC address. And then when they renew their lease, they get online. But there's a whole nother system for taking them back offline. And it's actually fairly sophisticated. We have web services interfaces to our DHCP servers and to a black hole route injection system that uses BGP to inject routes, and it ties into our snort and bro intrusion detection systems and our NetFlow detection system. And so when something is detected on the network through snort or bro or NetFlow or whatever it may be, there's web services interfaces to block the traffic, to unregister their MAC address, to tell the system, the captive portal system, why they got kicked off the network. So when they come back into the captive portal, it tells them how to remedy whatever it was. So it's a fairly sophisticated system. So we've started building out the system with OpenFlow. So the first piece of this is in the top left part of the diagram is our IDS cluster. So the first thing we ran into is we just can't scan enough data, right? We like snort, we like bro because they're open, we can build all this tie-ins into the system, but we need to scale it more. And so our security office came to us and said, we need to build a big cluster. We need to pipe all the span feeds from all the core routers into one box, and then we need to load balance that across a huge IDS cluster. And they asked for a huge chunk of money to do that. And when I started drilling down on what you really need out of that, it was really simple functionality. There's boxes today, appliances you could go buy. Some of you in the room may make some of those or sell some of those. And they're great devices. I don't want to say anything bad about those. But what we wanted was one little piece of functionality. Those boxes you can buy do 200 other things that we didn't want to buy. And we started looking at it, we were like, this is an obvious play for OpenFlow. And so we hired a master student and stuck in with a professional developer, and about a year later we now have a production system. It uses the top-of-rack switch that we already had, takes an OpenFlow controller, and it basically injects OpenFlow rules into that top-of-rack switch to distribute the load, can rebalance load and take into consideration when a server goes down. So now we have, I think, on the order of 30 or 35 servers doing intrusion detection for our whole network. And we have about $30,000 invested in that system. We've open sourced that. So that's the first piece of it. But the next piece is then to take all these other mechanisms, using DHCP and BGP to affect attack mitigation on your network is probably not the best way to go about it. It's a pretty coarse granularity of control. We really want to start building into that NAC system the ability to go into the routers, to the switches, to the firewalls, and start blocking that traffic using OpenFlow. Much more dynamic and much more granular in terms of how we can block things. You can also do other things like mirror the traffic. We'd really like to be able to pick out things we see that we may not be 100% positive are an attack, mirror that traffic back to a system, look at it more deeply, and then take action. The last one I wanted to talk about comes back to application-driven networking that Steve talked about. And so this is actually, Steve mentioned InCenter, which stands for the Indiana Center of Network Translational Research and Education. So we do have the SDN Interoperability Lab, but we're also doing network research, and our lead of our network research is Dr. Martin Sweeney. And this is something that he's working on called the Extensible Session Protocol. So I showed video as a use case here. Our use case, our near-term use case, is actually moving very large scientific data sets around, whether it be human genome data or Large Hadron Collider data. But I thought the video, it applies equally to video, and I thought that would be more generally applicable. The idea is that you have a network that has some special network requirement, whether it be bandwidth, whether it be jitter, or whatever that would be, firewall policy. And you want that application to be able to signal to the network. A lot of times you see with these applications, they try to guess what the network conditions are, how much bandwidth is available, and then the video will adjust its bandwidth accordingly. What you really want to be able to do is have the application just simply signal the network. And so that's what this extensible session protocol does. We've actually done some demos of this on live networks. And it basically is a way for the application to signal to this thing called the XSP daemon what it wants out of the network. And it's actually a two-way conversation where it can say, I want to do 50 megabits for my video. Is that available? And the daemon can say, no, it's not available, and you can negotiate down. But then it talks to an OpenFlow controller, and then that OpenFlow controller can go off and actually provision the network. That could take the form of, say, building a VLAN, a circuit from place to place, setting QoS settings, as Steve talked about. HP has a similar demo to that. It could also take the form of dynamically opening up firewall policy. Say if you're doing a video off-site, it can actually negotiate that. The connection between the application and the XSP daemon is actually authenticated and authorized, so you know that application is authorized to get the network requirements that it's looking for. So we think these are all compelling use cases for us. This all really boils down to, in my mind, management simplification. If you come back to the controller-based wireless scenario, we could probably do the things we're doing today without controller-based wireless, but we couldn't do it with 2 people running 5,000 access points. No way. And we would have had to gone back and asked for a whole lot more people to do that. So it's about enabling you to do things you simply couldn't do if you didn't have that sort of simplification.